Hey, so now it's our turn to take up the question for our discussion, that is question number 26. Again एक 2 mark का question है. इस question में हमसे पूछा गया है use Bohr's model of hydrogen atom to obtain the relationship between the angular momentum and the magnetic moment of the revolving electron. अगर आपने पेपर से पहले प्रीवियस ईयर के पेपर्स सॉल्व किए हैं तो आपने देखा होगा ये क्वेश्चन बहुत बार पूछा जाता है. सो आई विल से दिस इज अ वेरी स्ट्रेट फॉरवर्ड डेरिवेशन दैट हैज बीन आस्क्ड मल्टीपल नंबर ऑफ टाइम्स इन द CBSE बोर्ड एग्जामिनेशन. सो लेट्स हैव अ लुक ऑन टू द डेरिवेशन. किसी भी और डेरिवेशन की तरह आपको इसके अंदर भी पहले पूरे एक्सप्लेनेशन लिखनी पड़ेगी कि लेट अस सपोज वी हैव दिस इलेक्ट्रॉन which is having the charge minus E that is revolving uniformly around a stationary heavy nucleus plus E of hydrogen atom. So this is the hydrogen atom, the nucleus, electron that is revolving. Okay. Now here, as this electron is revolving, so this is going to constitute the electric current. Current will be charge divided by time. This time is the time period of revolution of this electron. Now here if I say that this orbit in which the electron is revolving has the radius r and VE is the orbital speed of the electron, then we can simply write the time period as 2 pi r by V. So that will be 2 pi r by VE. Okay. Now here if we just substitute the value of this time in the first equation that we have written to calculate the current will come out to be this. Now what is the magnetic moment? That is current into area. So I into pi r square. When you will be substituting the values, you can easily get this mu E, that is the magnetic moment of this revolving electron, as EVR by 2. Okay. Now this magnetic moment is a vector quantity. So there is going to be the direction that will be associated with this, that is going to be into the plane of the paper, because this will be decided by the current. So current here is in the clockwise direction, so this will be into the plane of the paper. Okay, now here in this question we were not just asked to find out the magnetic moment of this revolving electron. We need to find out the relation between the magnetic moment as well as the angular momentum of this electron. So what we need to do is, if we just multiply and divide this expression with the mass of the electron, what we will be getting? We will be getting in the numerator a term mvr. What is mvr? That is the angular momentum. So we can replace this with L, where L is this is the magnitude of the angular momentum of the electron about the nucleus, which is mvr. Okay. Now here in the vectorial form you can also write it like this. Now let me just explain you about the marking scheme for this question. So you will get half mark for writing the derivation till here. आपको another half mark मिलेगा जब आप t की वैल्यू सब्सटीट्यूट करके I की वैल्यू निकालेंगे. आपको another half mark मिलेगा जब आप मैग्नेटिक मोमेंट का फॉर्मूला करेक्ट लिखकर इसकी वैल्यू फाइंड आउट कर लेंगे. और आपको अनदर हाफ मार्क मिलेगा जब आप इजीली मैग्नेटिक मोमेंट और एंगुलर मोमेंटम के बीच में रिलेशन फाइंड आउट कर लेंगे. सो दिस इज हाउ यू विल बी फेचिंग 2 marks फॉर दिस डेरिवेशन एज वेल. आई होप दिस इज क्लियर टू यू. नाउ लेट्स हैव अ लुक ऑन टू द सॉल्यूशन फॉर क्वेश्चन नंबर 27. दिस सेज इन अ सिंगल स्लिट डिफ्रैक्शन एक्सपेरिमेंट द विड्थ ऑफ द स्लिट इज इंक्रीज्ड. How will the size and the intensity of central bright band be affected? We need to justify our answer. So let's have a look on to the solution. अगर मैं single slit diffraction experiment की बात करती हूँ, we know angular width of the central maxima is given by the formula 2 lambda by A, where A is the width of the slit. Now on increasing the width of the slit, what will happen? On the size of the central bright band, that is going to reduce. Okay. Now if the size of the central bright band will reduce, what is going to happen to its intensity? Its intensity is going to increase. Okay, because as the size is decreased, now the intensity will increase. Okay. So this is how you will get 2 marks for this question. 1 mark for talking about the size and 1 mark for talking about the intensity of the central bright band on increasing the width of the slit. I hope this question is very clear to you, and I hope you will also fetch the maximum marks, that is 2 marks for this question as well. Now let's move on towards the section C, which includes the 3 marks questions of the paper.